All right, in this video, I'm going to show you how to write a polynomial using your graphing calculator. So we have a data set here, x and f of x, so that's like x and y. And directions say use finite differences to determine the degree of the polynomial function that fits the data. Then use technology, which is going to be our calculator, to find the polynomial function. So, first thing we're going to do is something called finite differences. And how that works is we're looking at our y values. And what we're going to do is we're going to find the difference, hence the word finite difference, of each y value. So what I'm going to do is I'm going to take the right value and subtract the left. So I'm going to do 20 minus 30. So 20 minus 30, that's negative 10. 4 minus 20, that's negative 16, so on and so forth. So I'm going to take right minus left, right minus left, right minus left, right minus left, right minus left. So I'm going to, let you know what I'm doing, I'm going to write out the remaining numbers. So negative 20, negative 22, negative 22, negative 20. So took right from left, and what we're looking for is we're looking at the result, the numbers we get. If these were all the exact same number, the power on x, the degree of this, would be x to the first, because this was the first time I've done this process. So if all these were the same, what I would know is that this is a linear function. Since they're not all the same, we're going to keep going. So we're going to continue this process again. We're going to take the right number, so we're not up here anymore, we're this new row. Take right minus left, right minus left, right minus left. So I'm going to take negative 16 minus 10. Get negative 6. Right from left, right from left, right from left, right from left. So I'm not going to explain every single subtraction. I'm going to write out the numbers. So you're going to get negative 4, negative 2, 0, and positive 2. So again, what we're looking for is we want all of these numbers to be the exact same number. If they were the same, this was the second time we've done this process, so we would have x to the second power, which would be a quadratic. Since they're not the same, we're going to keep going. So again, I take right minus left, right minus left, right minus left, right minus left. So negative 4 minus negative 6 is 2. Negative 2 minus negative 4 is 2. 0 minus negative 2 is 2. 2 minus 0 is 2. So this was the third time I've done this. So the power is now x to the third power, making it cubic. So that's a cubic, that's a quadratic. This would be linear. And if I had to go one more time, it'd be x to the fourth and so on, right? So notice how I got 2, 2, 2, 2, so all the same number. So what I know is I now know that this polynomial of this data set, it's going to be a cubic, so x to the third power. So the only thing that's left to do is, I know it's cubic, the degree is 3, because it was the third time we did it. The only thing left to do is use technology to find the polynomial function. So this is very similar how we've done it with quadratics and linear and all that. So what we're going to do is you take your calculator, and first thing you're going to do is you're going to go to stat, and you get this full list, and the first option is edit. Now what we're going to do is we're going to plug in all the x values into list 1, which I've already done, and all the f of x values, which represents y, into list 2. So for the sake of time, I've already plugged all of those in. So if you haven't done so, maybe press pause and go ahead and put those in. Once you have them all plugged in, we're going to go back to the stat button, and we have a whole bunch of options. We don't want to edit anymore. We want to calculate what the function is. So I'm going to hit an arrow to the right to go to calc. Now we have options here. Number 4 is linear. If we would have had this top one have all the same numbers, we'd be at linear. Next is quadratic and cubic. So we're going to go down to cubic regression because, well, that's what we found using finite differences that this was a cubic. So I'm going to be at the cubic option, hit enter. And it's already, if you use list 1 and list 2, it's already by default going to use list 1 and list 2. So we're going to go down to calculate and hit enter. And what the calculator is going to do is it's going to come up with the equation that fits this line. Now you see I have a lot of decimals there. I'm going to do some rounding here. So they tell you at the top the form of it, y equals ax cubed plus bx squared plus cx plus d. So I'm going to have y equals 0.33. I'm going to round to 2 decimal places. 0.33 x cubed minus 5x squared, which was my b, plus 2.66x, which was my c, and then d, which plus 32. Oh, didn't realize it went off the screen. Plus 32. So I took the information from my calculator and came up with my cubic polynomial. So now I have that, and that is writing a polynomial using a calculator. So you have to start with finite differences, because sometimes you'll get a cubic degree, sometimes you'll get the quartic x to the 4th. So you got to figure out which one to use when you go to the calculator, and then you just copy the information down from your calculator.